we have already seen how to convert the quadratic form into canonical form. If in the question index and signature is asked, what is index? It is the number of positive eigenvalues. In this case, index is the number of positive terms present in the canonical form. How many positive terms are present in the canonical form? 1. So index will be 1. Signature is defined as the difference between the positive eigenvalues and number of negative eigenvalues. In this case, number of positive terms minus number of negative terms. Number of positive terms are 1. Number of negative terms are 2. So signature will be minus 1 in this case. Now next example is find the change of variable that reduces the quadratic form to the sum of squares and express in the form of new variable by using orthogonal transformation. The word orthogonal transformation is used. In the previous example, to convert the quadratic form into canonical form, we were finding matrix P such that P transpose A into P is a diagonal matrix. So we started with A is equal to I3A into I3. Now in this example, we are not going to use this concept. We know that a matrix is said to be orthogonal if A into A transpose equal to identity matrix or A transpose is equal to A inverse. We are supposed to find the P matrix such that P transpose A into P is a diagonal matrix. So in this case, as it is orthogonal, P transpose will be equal to P inverse, means we are finding a P matrix such that P inverse A into P is a diagonal matrix. And this is a question of diagonalization. We have already seen how to find a P matrix such that P inverse A into P is a diagonal matrix. Okay. So this question reduces to the diagonalization problem. In this case, what we will do is first write the quadratic form into matrix form. Coefficient of x square, coefficient of y square, half into coefficient of xy, half into coefficient of xy. This is your symmetric matrix. Now write down the characteristic equation. What is the characteristic equation? Lambda square minus trace of A into lambda plus determinant equal to 0. Trace is the addition of diagonal elements. Find the determinant. Using this characteristic equation, find the roots. The roots or the value of lambda are the eigenvalues of the matrix. Corresponding to each eigenvalue, find the eigenvector using the process A minus lambda I into x is equal to 0. For lambda equal to 3, the eigenvector is minus 1, 1. For lambda equal to 1, the eigenvector is 1, 1. As the eigenvalues are distinct in this case and it is a symmetric matrix, so the given V1 or V2 will be orthogonal to each other, means the inner product will be 0. If the eigenvalues are not distinct, then we have to find a matrix, we have to find a vector which is orthogonal to V1 and V2. Okay. In this case, it will be orthogonal as the eigenvalues are distinct. It is orthogonal means what? The inner product is 0, means minus 1 into 1 plus 1 into 1 is 0. Okay, as the vectors are orthogonal to each other, next process is to normalize the vector. How to normalize the vector? V1 dash is calculated as V1 upon norm of V1 and V2 dash is calculated as V2 upon norm of V2. Where what is norm of V1? Square root of minus 1 square plus 1 square. Norm of V2 will be square root of 1 square plus 1 square. This is V1 dash and V2 dash. Thus the required modal matrix P is the matrix V1 dash V2 dash. These vectors are written in the column form. This is your P matrix. Now you can find P inverse AP. P inverse AP will give you the diagonal matrix, and we know that diagonal matrix in this case are the eigenvalues written on the principal diagonal and rest of the elements are 0. You can check that the first vector was for lambda equal to 3. So place lambda is equal to 3 at the first position. And the second vector was for lambda equal to 1. So place lambda equal to 1 in the second position. This is the required diagonal matrix. So the canonical form will be 3y1 square plus y2 square. So in this type of example, we already know what is the canonical form. The canonical form is nothing but the eigenvalues written on the diagonal. So canonical form will be 3y1 square plus y2 square, that is lambda 1 y1 square plus lambda 2 y2 square. This is the required canonical form.